evolution and modern science, and I think it's false, and I think the truth needs to be defended, and that we need to be armed with information to defend the truth. So we'll elaborate on why it matters further in talk 3 next month, but I hope this is uplifting tonight. It's very much uplifted and encouraged me, and I hope that I can share this with you and we can all be equipped to have a ready answer when we are faced with these questions. So that's promising. So in part 1, for those who weren't here and for those of us who were, it's been a long time ago, we looked at the origin of the theory that mankind came from Africa. We saw that there is a strong link between the theory of evolution and the theory that we came from Africa. We saw that one of the central concepts behind evolution is the idea of uniformitarianism. It's the assumption that the same natural laws and processes that operate in the universe today have always done so in the past in the same way. We then looked at what the Bible says about the origin of nations, the flood as recounted to us in Genesis chapters 6 to 9. It has a universal language that is used to depict what is clearly a catastrophic event. We looked at what Genesis 8 and 9 say about what happened after the flood, and the Bible seems very clear that from Shem, Ham and Japheth the whole earth was populated. And finally, in part 1, we looked at what the Bible says about the location of Shem's offspring, and we found that Shem is synonymous with the male gene group J. We'll clarify what this means this evening, but in essence, male gene group J is known to be Semitic, and some geneticists equate a particular subgroup of J with Abraham, and it reflects the movement of Abraham from Ur of the Chaldees to the land of Israel. So what we're going to do this evening then for part 2 is look at how we can tell what we can know, how does it all work, what is the out of Africa theory, is it reliable, does it conflict with the Bible account, and then we'll look at who and where is Shem to remind ourselves what we said last week in brief, and then who and where is Shem genetically. So, first, the idea of inheritance. We know we inherit characteristics from our parents and they from their parents. Our appearance is determined by our genes and by our environment. We inherit half our genes from our father and half from our mother, and so we inherit a quarter of our genes from each grandparent. Alternative versions of our genes account for variations in the characteristics that we inherit, and these alternative versions are called alleles. The presence of an allele does not mean that the trait will be expressed in the individual that has it. If the two alleles of an inherited pair differ, then one determines your appearance and is called the dominant allele. The other has no noticeable effect and is the recessive one. And this is why we may look or act more like one grandparent than the other three. The genetic information is carried by DNA. DNA stores, replicates and passes on all our unique characteristics, our genetic inheritance. These DNA strings hold the template codes for proteins, which are the building blocks of our bodies. Essentially, the DNA tells proteins what to do. We each inherit DNA from our parents, and because we receive a unique mixture from both, each of us has slightly different DNA strings from everybody else. Our DNA is like a molecular fingerprint. Now, during human reproduction, the parent's DNA is copied and transmitted in equal proportions. Most of the DNA is kept apart during reproduction, but small bits are shuffled and mixed at each generation. They recombine. However, there are two small portions of our DNA that do not recombine, and these two sections are easier to trace back through previous generations, since the information is unchanged during transmission from the parent to the child. The two portions are known as mitochondrial DNA, rather long word, and the Y chromosome. But when, let's take mitochondrial DNA, is passed on from mother to child, occasionally there is a change or a mutation in one or more of the letters in the code. The new letter is a point mutation that's then passed on through all the subsequent daughters. For the large part, these mutations are neutral, having no functional or health relevance. The mutations are the ultimate source of genetic variation through new versions of genes. They can change the way the gene functions or prevent the gene function. So we can use these mutations to construct a genetic family tree, because each new mutation, in the case of the mother, in the prospective mother's ovum, will be transferred in perpetuity to all her descendants down the female line. And each new female line is therefore defined by the old mutations as well as the new ones. So in this way, we can identify all the different combinations of mutations in living females around the world, and therefore construct a family tree back to the first mother. And this is therefore a picture of the female genealogy of mankind. In the same way, there's a set of genes that is passed down only through the male line. That's what we refer to as the Y chromosome, the defining chromosome for maleness. As I say, with the exception of a small segment, the Y chromosome does not get involved in recombination. And so, like mitochondrial, the non-recombining part of the Y chromosome remains unchanged, except for apparently random mutations. And so this can be traced in an unbroken line back to the original male ancestor. The Y chromosome has a potential for much greater power of resolution than the mitochondrial, because it's much larger, and so there's more potential for variation. But this also makes it much more difficult to be comprehensive. It takes an awful long time to look for mutations, and the scientists have to choose where to look. By looking at the DNA code in a sample of people alive today, and putting together the changes in the code that have arisen down the generations, we can trace our line of descent back to a shared ancestor and work out how we all relate. And by looking at where these people came from, we can see where the mutations happened, whether Asia, Africa, Europe, and their routes of movement. And in this way we can use the DNA to study the population history of mankind. Now, as an aside, this to me is incredible, because God, to me, has allowed this to happen, to allow us to find these things out in these last days, to verify it within the science that we're all related, that we all came back from one person. I won't go through some of these definitions, but they're on your sheet. Natural selection, genetic drift and gene flow, they're the main means by which mutations happen, by which things can be mapped. One thing to notice with genetic drift is that it has more of an effect in a smaller population than a larger one. And in the last few years, the consensus is coming to the idea that genetic drift has more effect than natural selection, which is very, very interesting. Also, population bottlenecks. This is a term for a sharp reduction in the size of a population due to environmental events, such as earthquakes, floods, fires or droughts. So we'll move on swiftly. So the out of Africa theory. It's the African origin of modern man was first proposed by Charles Darwin, and it's become the established theory as to where we all came from, to the extent that it's now presented to us as fact by media and by popular authors, and I've no doubt in science textbooks in schools. The theory is based primarily on observations of the remains of humans and estimations of their age. The original hypothesis contends that the last expansion out of Africa occurred about 100,000 years ago and resulted in modern humans displacing all previous hominins in Eurasia and elsewhere that had been the result of an earlier wave of migration out of Africa. An alternative hypothesis, the multi-regional scenario, claims individuals from this expansion out of Africa intermingled genetically with those earlier migrations. The out-of-Africa theory was speculative until the 80s, when studies were published which presented genetic evidence that, along with archaic specimens, was said to corroborate the theory. The principal study was published in Nature magazine in 1987. And since then, a larger number of studies over the course of the last 25 years have sought to add clarity and to calibrate genetics with the archaeology. What those first studies did establish was that all people alive today share a single point of origin. However, the authors of that study concluded that older human species, such as Neanderthals and Homo erectus, have become extinct, and that our ancestry is purely Homo sapiens. Since then, various studies have shown that this conclusion is wrong, that archaic humans, such as Neanderthals, have contributed to the modern person's gene pool. This is achieved by extracting DNA from ancient human remains. So the out-of-Africa theory has been adapted in recent times to reflect that modern humans expanded after leaving Africa and interbred with other hominins, apparently different kinds in different parts of the world, including Neanderthals. Now, these findings are definite. They've been able to show that, for example, Europeans have between 1 and 5% Neanderthal DNA, and Southeast Asians have up to 10% of an archaic DNA. But what's not definite is how that DNA got there, and we'll come back to that in part 3. The origin of our mother in Africa has changed over time. Some textbooks will say North Africa, some say Central Southern Africa, but the predominant position today is of a single origin in East Africa. But there are different theories as to whether there was one exodus or several, and also where that exodus was. Some say across the Red Sea, near the southern tip of Arabia, some say North Africa. So this is a map showing the out-of-Africa theory as it's presented. It's noticeable how they can't decide on the origin. You've got various points here in Central Africa, and you've got there the crossing over that southern route out of Africa. The idea is that they then moved over the Persian Gulf, down through India, some turned back and moved into the Middle East and Europe, and the rest carried on into Southeast Asia, and some up towards China and Japan. That last map was a map of the mitochondrial, the female DNA. This one's the male, showing a very similar picture, again starting in Africa and then moving into the Middle East and then dispersing from there. And this one's back to the female DNA, and what's interesting here is it's got a convergence point in the Middle East. You'll see there where all the red lines congregate around the letters N and M. We'll come back to why that's interesting later on. So, is the theory reliable? Well, you'll be hard-pressed to find anyone in science who doesn't contend that the origins are in Africa. It's an ingrained philosophy within academia. New information that comes to light is accommodated into this theory. There are some geneticists who disagree, but you have to dig deep to come across them. Mutations. Very few people, if any, seem to have questioned the initial assumptions about the direction of mutations. Perhaps this stems from the first assumption regarding the African origins. If a difference in the gene is observed between a group of people, and you can divide this group into two groups, one with version A, one with version B, and those with version A are African, well, the mutation must have come from Africa, so it goes from A to B, rather than B to A. So, to put this into pictorial terms, if you start off with the assumption that your origins are in Africa, and that mutations happen in a certain direction because of that origin, you're going to conclude that the greatest rates of mutation are found in Africa. You'll then assume that the places where the greatest rates of mutation must be home to the oldest lineages, and therefore indicate the origins of mankind. It's a nice bit of circular reasoning. Mutation rates. Scientists assume that the point mutations happen at a consistent rate. This assumption, together with the African origin assumption, combines to give the idea that mankind evolved in Africa so long ago. Now, those in the field do admit that because of the nature of mutations, the dating is only approximate. Now, the Y chromosome is particularly exposed to high mutation rates, and the principal cause of this is environment. It's at a greater risk of mutation than the rest of the entire genome. Interesting quote for you. It's from Murray Cox. Considerable caution should be applied to inferences made from molecular dates, many of which may be misleading and warrant considerable scepticism. Demography is a strong confounding factor in estimating these dates accurately, especially for populations in which bottlenecks, founder events, and size changes have played important historical roles. Now, if the population of the world came from Noah, that's an extreme bottleneck. And when his offspring dispersed, those will be founder events. An accurate estimate of the mutation rate is essential to dating and interpreting demographic events inferred from these dates. And this, essentially, you need to have an accurate sense of the mutation rate in order to be able to map the genetics with history. So, mutations arise through, firstly, copying errors that arise during replication, and secondly, DNA changes that occur spontaneously because of the instability of DNA structure, or are induced by internal or external sources. Being able to date successfully when these things happened is heavily dependent on correctly estimating the mutation rate. There's lots of discussion and disagreement between scientists as to the mutation rates, a number of factors which affect this rate. And those are summarised on the screen there. The father's age is the first one. There's a clear increase in the number of mutations with paternal age. And also the time between generations has an effect. Secondly, the environment, including ultraviolet light and other radiation, carcinogens, free radicals, and diet. And thirdly, the effective population size. It's suggested that a population with a smaller effective size will experience a higher per generation mutation rate than would a large population. So while scientist models have assumed mutation rates as constants, it's now clear from a number of factors which affect mutation rates, this isn't the case. And this is now widely acknowledged in the genetics world. The possibility that mutation rates are rapidly changing brings in uncertainty about the dating of a population movement from genetic data. And which mutations? There are nearly 60 million pairs of proteins in the Y chromosome. So looking for mutations is rather like looking for needles in haystacks. You have to look, they don't present themselves to you, and therefore it depends where you look as to what you find. If you expect to find certain mutations, perhaps those more prevalent in Africa, you will look in those places on the Y chromosome. If you don't look in other places, you won't find. The mitochondrial DNA has far fewer pairs of proteins, about 16,500. And 440 of these, a small section, is used to work out maternal ancestry. Genetic diversity is another assumption. We're all familiar with the term homogeneous. If a group is homogeneous, there's less variety within that group. It is said that the human population within Africa is the least homogeneous. There is a greater variety of genetic characteristics in Africa. In addition, the population becomes more genetically diverse as a way of adapting to changing environments. The more variation within the population, the greater chance there will be of individuals who have versions of genes that can suit the environment. Clearly, the environment has a bigger part to play in genetic diversity. We know that Africa is home to many of the world's extreme environments. There's also high genetic diversity in southern and eastern Asia and in eastern Turkey and western Iran. Yet those parts of the world are not said to be the origin of mankind, apparently. And we have to ask, why not? Diversity increases with isolation. If the population becomes isolated, they'll mix less frequently with other populations. The oppressive environments within Africa will have led to increased isolation, as people concentrate on surviving rather than on mixing. The other reason proposed for diversity in Africa, particularly, is a large effective population size. But here again you have the assumption that the higher population size is the host or origin, and that people migrate from that larger population. There are other explanations as to how Africa came to have a large population size further back in history. The theory of out of Africa assumes genetic contributions from archaic human species to be minimal, and as we said, the initial population replaced others outside of Africa. This is a source of considerable disagreement between geneticists, and as we said earlier, there's growing evidence for what science sees as the interbreeding of modern humans and archaic humans, such as Neanderthals. Another assumption is, there's a quote there actually, from a paper last year, on genetic grounds, the out-of-Africa model is decidedly out of date. In order to better capture the genetic scenario of modern human origins, a new improved model must include spatial dimensions. Another assumption is archaeology. The assumption being that the oldest archaeological evidence of humans is found in Africa. The evidence is said to support the out-of-Africa theory, but it assumes a continuity with no worldwide flood and no break in activity. The evidence is sparse and requires a great deal of supposition. There are large gaps in the archaeological record, including in Africa, and we know that the earliest remains of Homo sapiens are found not in Africa, but in Israel. So, does the theory accord with the Bible account? Well, the out-of-Africa model assumes continuity over a very long period of time, and the Bible says different. In assuming continuity and no breaks, the model leaves no place for a global flood. But it also leaves no place for a Genesis flood that was local to the Middle East, unless that flood was simply a river bursting its banks. But that doesn't fit at all with the Genesis account. It would mean some people never left Africa. This requires a flood local to the Middle East, and this lacks genetic evidence. And we saw in part 1 of our study how that the language in Genesis is rather more universal than required by local flood. The out-of-Africa model means Eden being in Africa, presumably. Inherent in the theory is the idea that we have evolved from primitive ape-like creatures and have slowly improved over time. Not only does this go against the principle and evidence that the majority of mutations are negative rather than positive, also embedded in it is the rather Victorian idea that Africans are primitive and that Western society or the developed world is more superior. It requires lots of generations before Shem and lots of generations between Ham and Shem, meaning that Shem, Ham and Japheth can't be brothers, if indeed they could exist at all. We can see this here. This is a simplified family tree using the Y chromosome. The main African lines are highlighted in the red box and the Semitic line in the purple one. And you can see the problem. Shem appears much further down, and the Africans are apparently earlier on in the family tree. Now this is on your handout, and it's how the various groups of the female DNA all relate. The L groups, top left, are the supposed origin in Africa. And the three major groups, which the majority are said to come from, are M, N and R in the middle of the chart. Now these three are of a very similar age. They're all related very closely. But there's nothing here which says that the origin has to be top left. We've got the idea that there are three major groups and other groups emanate from these three. And if you look at these three and they're spread around the world, a pattern emerges. You've got the columns of the three major groups, M, N and R, and the various regions of the world. We can see that there are members of each of these three groups, all in different regions of the world, all around the world. Which I think is very intriguing. You've got the idea, well, over history, society's been very patriarchal. Women are generally left to join the husband's group, and so female DNA will have been mixed up around the world. There'll be no sort of overall pattern, as we'll see in a while with the Y chromosome. This is the Y chromosome, the male DNA family tree. The A groups on the left are supposed to be the origin. What we can say is that the gene groups to the left of the screen are more diverse from the groups to the right, Q and R for example. Now they're all related, there's one origin, but it's difficult to spot that. So, is the theory reliable? These are some quotes from Robert Bednarik, who's a world expert on rock art. There were right from the start significant methodological problems with this African Eve theory. The initial computer modelling failed. Based on 136 extant mitochondrial DNA samples, it arbitrarily selected one of a lot alternative and equally credible haplotype trees. Madison demonstrates that a reanalysis of this model could produce 10,000 trees that are more parsimonious than the one chosen by these authors. 10,000 trees. And they can all explain the evidence. Same chap, same paper. As Gibbons noted, by using a modified putative genetic clock, Eve would not have lived, this is the African Eve, 200,000 years ago, as Can had contended, but only 6,000 years ago. So that sense shivers up my spine. The story of how it rapidly became the dominant model in human evolution, and how for over 2 decades it determined what could be published in mainstream venues or what kind of research would be funded, not only rivals the history and the effects of the Piltdown hoax, it exceeds it in terms of its consequences. How is it possible that an entire discipline was captivated by a paradigm that, upon careful reflection, was always improbable? And that's from just over a year ago. So, is there a more rational interpretation? Well, in part one we looked at who and where Shem may be genetically. We saw that the male gene group J is Semitic. Its origin was eastern Turkey and the Zagros and Taurus mountains, and the likely area of ancient diversity of group J. Group J separated out into two major subgroups, J1 and J2. A high proportion of Jews and Arabs are a particular subgroup of J1 called JP58. Group J1 is common in North Africa, Ethiopia and Northern Sudan today. I noticed in studying for this talk that Jeremiah 44 talks of a great assembly of Jews living in Pathros, and that's where that concentration is today. Group J2 originates in the northern Fertile Crescent. and its hub is Western Iran, Iraq, Turkey and the Eastern Caucasus. So we'll spend, actually this is a map, that's the map of gene group J. So the origin is indicated by the green dot, and you can see there the darker shades are the highest concentration, and movement to the west of that black line is relatively recent, with the Jewish diaspora in Europe and the Muslim caliphate in North Africa. So, Ham. Who is Ham genetically? Well, for Cush, where the Hebrew word means black, the Bible and historical evidence all clearly points towards Ethiopia or Nubia. There's a quote from Isaiah 18. "The land of whirring wings that is beyond the rivers of Cush, which sends ambassadors by the sea, vessels of papyrus on the waters. Go, you swift messengers, to a nation tall and smooth, to a people feared near and far, a nation mighty and conquering, whose land the rivers divide." And that section also talks about heat, the clear heat in sunshine, the cloud of dew in the heat of harvest. And there are various passages in the Bible which parallel Cush and Egypt, Psalm 68, Isaiah 20. In Ezekiel 29, Cush is said to border Egypt. Jeremiah 46, warriors from Cush handle the shield. There are other references, but we can establish that Cush is associated with a land southward of Egypt, Ethiopia or Nubia. And various peoples in that region today claim Cush as their ancestor. For Mitzrayim, the Bible and historical evidence all clearly points towards Egypt. Indeed, apart from Genesis 10 and 1 Chronicles, the word is translated in the Bible as Egypt and Egyptian, and Mitzrayim is known as Egypt from as early as Genesis 12, when Abraham goes down to Egypt. Mitzrayim is the Hebrew and Aramaic name for the land of Egypt. The Arab name is Mizra, pronounced Mazra, I think. Ezekiel 29 has a valuable clue as to the origin of the Egyptians. "I will restore the fortunes of Egypt and bring them back to the land of Pathros, the land of their origin. And there they shall be a lowly kingdom, never again exalt itself above the nations. And I will make them so small that they will never again rule over the nations." So its origin is said there to be the land of Pathros. For Put, the evidence is more sparse. Put appears in Jeremiah 46 alongside Cush, is named alongside Persia and Lud in Ezekiel 27, and Persia and Cush in Ezekiel 38, in both cases with shield and helmet. It's named alongside Cush, Lydia and Libya in chapter 30 of Ezekiel, and alongside Cush, Egypt and the Libyans in Nahum chapter 3 verse 9. And there are two of those quotes there. Nahum 3 verse 9, "Cush was her strength, Egypt too, and that without limit. Put and the Libyans were her helpers." These verses have two themes. The ones there and the other ones that mention Put. The two themes being that Put's descendants are warriors, and that they are supporters of or subjugate to others. Josephus identifies Put with Libya, and Pliny makes a connection with Morocco. There's little else in historical evidence. And while Nahum 3 could be used to show Put is Libya, Ezekiel, in mentioning Put and Libya, either side of Lud and Arabia, seems to suggest otherwise. For Canaan, of course, the identification is altogether simpler. This is a whole study in itself, but in summary, Canaan had two sons, Sidon and Heth, and their territory is named in chapter 10, verse 19 of Genesis. Four of the 9 Canaanite tribes in that chapter are names of settlements in the land around Sidon. We've got Arca in the north of Phoenicia, Arvad, which is 2 or 3 miles from the coast of Lebanon, Zemar between Arvad and Mahalata, and Hamath in Upper Syria. Other than Hamath, there are no further references in the Bible to these northern Canaanite tribes. Sidon is a settlement on the Mediterranean coast, inhabited since very early prehistory. The Jebusites, Amorites, Girgashites and Hivites are all resident in the land when the Israelites enter it. And as we know from Exodus chapter 3, they are supposed to be destroyed. In Exodus 33 verse 2 on the screen, God says, "I will send an angel before you, and I will drive out the Canaanites, the Amorites, the Hittites, the Perizzites, the Hivites and the Jebusites." And chapter 7 verse 1 of Deuteronomy, the Lord God says that he will clear away many nations from Israel. And this comes to pass in Joshua chapter 11. But in Joshua 13 we read the land still to be conquered, and in Judges of the Canaanites persisting in dwelling in the land. We read of Canaanites who were left, and in 1 Kings 9 verse 20, the people whom Israel were unable to devote to destruction. So the question is, did God blot out the Canaanites? These verses suggest it was a promise, and we can be sure that God keeps his promises. So it would be interesting to see whether the genetic evidence can help us answer this question. So with the map to help us, we've got Cush originating in Ethiopia, Egypt's origin at its southern border, Lake Nasser, and there's Canaanites, the Canaanite origin there. So in looking at the evidence, we'll focus on the male gene group, as it's easier to spot movements of groups of people. As we said earlier, society in Bible times and since tends to be patriarchal, women tending to come into the group led by a patriarch, rather than the man leaving the family to live with the woman's family. We'll begin with Mitzrayim. This is a map of the subgroup of the male group E. So we read of the origin of Egypt being in Pathros in Ezekiel 30. The origin of group EM78, which is a sub-part of this group, is in the same place, around Lake Nasser. And EM78 is the major element of the group on this map, and it's the lead gene group in Egypt. As the first major superpower, people flowed in and out of Egypt, and particularly in the north of Egypt, a sizable proportion of people are Semitic in origin. But even amongst northern Egyptians, EM78, the lead part of this group, is the lead gene group in Egypt. But the origins of Egypt as a nation are at its southern border with Sudan, and that's confirmed in Ezekiel 30. The evidence is very strong that Egypt is in Group E. I would suggest that Mitzrayim is synonymous with Egypt in the Bible, because in Israel's experience, Mitzrayim was Egypt. And of course, the focus of God's word is on his people Israel. So to repeat, Mitzrayim for Israel's experience was Egypt. Egypt forms a major element of Group E, but in genetic terms, Mitzrayim is more than Egypt. While we're on this slide, it's worth pointing out that as Group E comes from one person, the Put, who is son of Ham, can't be Libya, because Libya is up to the north there, to the west of Egypt, and it shares a very similar genetic makeup with Egypt. So Group E originates in Ethiopia. Group E today covers much of Africa, but much of this coverage came in recorded history with the Bantu expansion from sub-Saharan Africa southward, and these lines are very simple depiction of what happened. So over time, Group E moved into the Sahara Desert, then it desiccates, people move northward and southward, and then in the last 2,000 years, the Bantu people have moved southward, and the southern half of Africa is now full of people with Group E. Now, people in Group E share a very rare mutation with those in Group D. Back to our gene tree to remind us, we've got their D and E come from one origin, they come from one person. So who are Group D? Well, not many people. That's a map trying to show the makeup of, or the spread of Group D. Tibetans and the indigenous Japanese called Ainu. Now, Group E and Group D must come from one man, but how is it that they're so far apart? We come back to God's command to Noah and his sons to multiply and fill the earth. So where do Groups D and E originate? Well, it's somewhere clearly between Ethiopia and East Asia. You may not be able to see, but on this slide, the suggested origin of Groups D and E is the Tigris and Euphrates, somewhere in the Middle East. So Kush, this is a map of male gene group A. Kushites were known for their skin colour, and they were a distant people from a hot, remote place. That's a sort of the sum of the quotes from the Bible about Kush. The most popular element of gene group A is in Ethiopia and Sudan. If rather than start at, let's see if we've got, yeah, if rather than start at A00, where the origin is said to be today, we were to start from somewhere nearer to Group J, where Shem is, and look for the direction of mutations in the opposite direction, then the origin for Group A is the east coast of Africa. Shown by the red star. So the Outer Africa theory says that they're not quite sure where A starts from. It could be West Africa, Central Africa, Southern Africa. But if you look in the opposite direction, with an origin in the Middle East, coming from in the opposite direction, then the origin is very, very clearly in Ethiopia, in a very similar place to Group E. So this is Group B. And today, Group B's highest frequencies are in hunter-gatherer groups of Ethiopia and Sudan. Now, I would suggest that Groups A and B come from one man, and that the prime candidate in our study is Kush. So if we look back at the original dream family tree, everyone left of F, which is circled, shares a mutation. If you go from right to left rather than left to right, everyone left of Group F descends from one man. Now these two are hypothetical groups. There's nobody alive today that is in these two groups that I've crossed out. So that leaves just Group C. So under the theory that I'm putting forward, Group C is either Put or Canaan. Now Group C's origin is said to be the Persian Gulf, as shown by the red star. But for reasons we'll come to in part 3, Group C doesn't have a presence today in the Middle East in a number. I would suggest that the reason Put is so little known in history is because he was so little known in the Middle East. He wasn't a factor, a player in the story of Israel. Where Put is mentioned in the Bible, it is in armies with Cush, Egypt and Persia. This is a map of Group C2, one part of C, and Genghis Khan is a famous member and supplies most of that map. So, and these are sort of origins put forward as the origin of Group C. So back to the male gene family tree. These groups we've looked at are extremely closely related, separated by very few mutations. and I would suggest that these are all the sons of Ham. There's no sign so far of Canaan, which is very interesting. The land once occupied by Canaanites is now predominantly Semitic, with an influx from European groups, including the Sea peoples and those from the Caucasus. Is this a sign, perhaps, of God's promise fulfilled? So, in summary, we've looked this evening at the principles behind genetics and how we can find out what we can know. We've looked at the out of Africa theory, its assumptions and its unreliability. We've seen how it conflicts very clearly with the Bible record. We've looked at the female and male gene family trees. We've looked at there's very strong evidence for Mitzrayim being groups D and E, and that Egypt is historically the lead element of this group, in population terms as well as in historical terms. There's similarly strong evidence that Cush is groups A and B. A lot of people with groups A and B think of Cush as their ancestor, and a great proportion of those groups speak languages that are Cushitic. And group C is an extremely close relative of groups AB and DE. So could it be put? It's been a whistle-stop tour, lots of information. But in part 3, we'll bring it all together. We'll look at who and where is Japheth genetically. We'll look at the theory as to what happened after the flood, allowing the genetics to add detail to what we see in the Bible account. We'll look at how God's word and prophecy has been fulfilled. We'll look at how we can apply this knowledge to our walk to the kingdom. And we'll ask why this is important. Why does it really matter? Thank you.